Good morning, friends. Today we are going to continue the next part of the unit 2 of the paper 2 of the physics. We have seen the here in the first lecture of this particular the different types of the nuclear reaction. Now we are going to discuss the conservation law. In any type of the nuclear reaction, certain quantities must be conserved. Following are the various conservation laws that are appear to be valid in the ordinary nuclear interaction. Conservation of energy, you know the total energy of the products including the both mass energy and kinetic energy of the particle plus the energy involved must be equal to the mass energy of the initial ingredient plus the kinetic energy of the bombarding particle. Conservation of the momentum, the total linear momentum of the product should be equal to the linear momentum of bombarding particles. Then conservation of angular momentum, the total angular momentum composing the vector sum of the intrinsic angular momentum S and the relative orbital angular momentum L of the product must be equal to the total angular momentum of initial particle. That you have to remember, it may come for the MCQs. Conservation of charge, the net charge of the product must be equal to the net charge of the initial particle. The conservation of the nucleons, the law of conservation of nucleons state that nucleons can neither be created nor be destroyed. The total number of nucleons minus the number of antinucleons in the universe remains constant. Also, along the three more laws of conservation are also valid, namely conservation of spin, conservation of parity, and conservation of isotopic spin. Mass and energy conservation in nuclear reaction. You see, the conservation of energy and momentum imposes certain restrictions. The restrictions are called kinematic restrictions. It may come for the MCQs, where X is the target nucleus and small x is the bombarding particle. It will give you the Y is the product nucleus and the small y is the product particle. Assume that the target nucleus is rest, therefore its kinetic energy is 0, and from above discussion, mass and energy is conserved in the nuclear reaction. Okay. Here you can see, after applying all this in equation, you will get mx square plus E1 plus m1 c1 square is equal to that. Energy equation is there. We are not going in detail of such equation. Then a new quantity will come in picture, that is a Q, which represent the difference of the Ke of reaction product and the incident particle. Q is equal to Er plus Ey minus Ex. That from equation 4.1 and 4.2 we get Mx that values. The quantity Q is called as the energy balance of the reaction, or more commonly Q value of the reaction, called as the energy balance of the reaction. It may come for the MCQ, which can be determined using this equation and is equal to the change in the total net rest mass energy. If Q is positive, the reaction is said to be exergic or exothermic. That may come for the MCQ. If the Q is negative, the reaction is said to be endoergic or endothermic. Exergic, exothermic means heat is lost and heat is absorbed. Okay, here in terms of the reaction, the sum of the masses of an incident and target nucleus is greater than that of the masses of the product nuclei. Okay, also the Ke of the product nuclei being greater than that of the incident particle. This is exact reverse of this.